All right, so we're going to take a look at section 4.7 now, talk about inverse trigonometric functions. So the inverse or opposite operation for sine, cosine, tangent, secant, cosecant, and cotangent. So we're going to look at how do we undo that relationship. So today we're going to look at all of the sine, cosine, tangent functions and their inverses. So this is going to be our essential question today. How can I evaluate and graph them? What do they look like? And be able to work with them to kind of get us towards being able to solve equations again with trigonometric functions. So let's jump right in. So I want you to go ahead and pause the video. I want you to graph one complete period of sines. We're going back to that original graph of what sine is, so then we can talk about what the inverse might look like. So remember what sine looks like when you graph it, and go ahead and make a one complete period. All right, so hopefully we have a one complete period of sine there. So middle, max, middle, min, middle. Now remember what the domain and range are of this function, because technically this graph is going to continue in both directions. So the domain, remember, was all real numbers. We can pick anything we want for our angle measurement. The range, it goes between -1 and 1. So we're pretty confident we know what that looks like. This is a function, that green graph, it passes the vertical line test, life is good. Okay, now think about what it means to be an inverse, where you switch the x and the y, the domain and the range. Now remember what's happening here. These were angles on the x-axis, right? And they were ratios on the y-axis. If we switch the domain and the range, we're definitely going to have a situation where we're going to have ratios on the x-axis then and angles on the y-axis. So we're switching the domain and the range. That's what it means for having an inverse. Now, here's the problem though. If you do the horizontal line test, remember the horizontal line test, and you pass that across this sine function, you're going to notice that it's going to touch 2 points at a lot of places. So that means, remember what the horizontal line test tells you, that if you touch more than 1 point, that means its inverse is not going to be a function. So that would mean that arc sine is not a function. We're going to have infinitely many values. Like if we just switch these two domains and ranges, and we said, okay, yep, the range here would have to be -infinity to infinity, and this would be -1 to 1. That wouldn't work for us. This wouldn't be a function. You can't have infinitely many places that could happen. So we're going to need to make an adjustment on this original graph. So I'm going to have you go ahead and go back one more point. So at -pi/2 or -90 degrees, sine would be -1, just going in that opposite direction, and it would keep going, right? We know that sine continues. I'm going to have you think about one particular part of this graph. So I'm going to use a highlighter here. Go ahead and highlight from -pi/2 to pi/2. If we just take a look at that part of the graph, -pi/2 to pi/2, we don't repeat any values. If you do a horizontal line test on just that highlighted part, it would only touch 1 point, and we would get all the different values between -1 and 1 that we need for sine. So what we do is we restrict the domain of the original function sine, so that when we flip and do the inverse, its inverse will also be a function. So we're going to make a restriction here. So I'm going to go ahead and have you write the restriction. We're going to go -pi/2 to pi/2, or -90 to 90 if you're working in degrees. If we just do that, we're going to be able to get a graph that its inverse is a function, which is what we're shooting for. All right, so I'm going to have you look at the 3 main points then that we're really going to need in this function. So if we're thinking about this graph, that part of the graph, we want to do its inverse. Remember how we take the ordered pairs here and we reverse them. So this ordered pair is -pi/2, -1. That means on the inverse, we're going to have -1, -pi/2. So we'd have that, that value. So I'm going to go ahead and see if I can get this going here. So -1 to 1, we'll go by pi/2. So -pi/2 will have 0 and then pi/2. So my first point then is at -1, -pi/2. 0, 0 would still be 0, 0, so that stays the same. And then this point up here would be pi/2, 1. So if we switch the domain and the range, it would be 1 pi/2. So when we look at our picture, if we look at our shape, actually what we're going to see is it's going to look like this. Now, if the graph continued, right, if it continued, we would have this, right, and this graph would continue going like this, and it would continue going like that. But take a look at the part with the dotted. If I do a vertical line test, then it would touch more than 1 point. So that's why I'm cutting it off. So the domain has to be restricted in the original function. So my inverse is also a function. So if you just look at that green graph, that is a function. It would pass the vertical line test. So if I switch my domain and the range, then my domain would be -1 to 1, my x values, those ratios, and the range is -π/2 to π/2. So that's how we're going to treat these inverse functions. There's not going to be infinitely many outputs. There's only going to be one, which makes it a lot easier for everybody to communicate. And remember the relationship between a function and its inverse, it has that reflection over the line y equals x. So that's why you see that curvature in the inverse going the opposite direction, so you can have that relationship. Okay, let's talk about how we actually find the inverse equation. So remember, we could do things graphically, which we just did, or algebraically. So if this is my original function, remember how to find the inverse. You just switch the domain and the range, the x and the y, and then we solve for y. So we're switching the domain and the range, the x and the y. That's finding the inverse. And then for convenience sake, we solve for y. And here's what I want to talk about, because that's how we get this inverse idea. We do the opposite operation to undo. If I want to get y by itself, I need to do the opposite of this function. Just like if you had square root of y, you would square both sides, right? To get y by itself, you do the opposite. This is the same thing. What is the opposite of sine called? Well, one word is arc sine. So I would do the arc sine on the one side of the equation, and I would do the arc sine on the other side of the equation, and I would be able to get this by itself. Because what happens if you do a function and then its inverse? You're left with y equals the arc sine of x. So arc sine, this prefix arc means inverse. Another notation for it is with that little -1, so you could have written it like this, and this would be inverse sine of x. Those two things mean the same thing. So at this step, I could have taken the inverse sine over here and the inverse sine over there, and it would have given me exactly the same thing. So those two mean the same. So it's switching the domain and the range, and we're limiting our domain of the original, so the inverse is a function. So what was the input angle? Output ratio, that's just flip-flop now. So our input variable is going to be the ratio, and our output is the angle. You're asking for what angle does that happen at. So let's kind of pull together what we know about sine then. The inverse sine function is defined in two different ways. You can say y equals arc sine of x, or you can say y equals inverse sine of x. Notice how I said that. Inverse sine, that little -1 means inverse. It's what's right above the sine button on your calculator. Kind of makes sense. The domain of inverse sine is -1 to 1, and the range of this arc sine is -π/2 to π/2. So we're doing kind of like quadrant 4 and quadrant 1. Gets all the values we need for sine. All right, so if you're going to do something like this, think about what this question is asking you. Find the exact value for arc sine of -1. What they mean is that you shouldn't have to type it on your calculator. You should just know what it is to get that exact value. So you're really being asked the question, for what angle is sine -1? So for what angle is sine of x equal to -1? You're trying to fill in that blank. Because remember, you're being given the ratio. Your answer should be an angle, right? For what angle is that happening? So you're trying to figure out what that value would be. So when is sine -1? Well, a lot of times we think about, well, I'm going to go back to the graph here, sine is -1. I think a lot of people naturally would jump on 3π/2. I can't answer that. I can't answer 3π/2. Why? It's not in the range of this inverse sine. We had to limit it. So we have to name it differently. So look at the graph. It is also -1 right over here at -π/2, which is in the range of my arc sine function or inverse sine function. So we have to just be really careful when we name these. So the answer to this question is -π/2. So when is inverse sine -1? For what angle does that happen? You're looking for that -π/2 value. So you're looking for that input. So for what angle makes that true? So be very careful with how you name your angles. And there should only be one solution that makes sense. We're going to practice that a lot. All right, let's do the same thing for cosine. So can you pause the video? Go ahead, graph one complete period of cosine. All right, so one complete period of cosine. Remember, initially here, our domain again is all real numbers, and the range -1 to 1, just like sine. Remember, they're cofunctions. They're just shifted π/2 from each other. We're going to do the same thing we did for sine. The issue that we have if we do a horizontal line, it fails. That means our inverse would not be a function if we did the regular graph for cosine. So we're going to do a restriction here. So I'm going to go ahead and grab my highlighter again. We're going to restrict to there. If I restrict just to that location, I'm getting the positive values once, the negative values once. If I pass a red like horizontal line up and down on just the highlighted part, I'm only going to touch one, and that gives me all the values that I need. So I'm going to make an adjustment to this domain. Instead of being negative pi over 2 to pi over 2, I'm just going to go 0 to pi, and I'm going to be okay then for my inverse. Okay, so remember how we find an inverse. We switch the domain and the range, so that means our domain now is going to be negative 1 to 1, and the range is going to be 0 to pi. All right, so let's go ahead and see if we can graph those points then. So I'm going to set up my scale for my inverse, and I'm going to go by pi over 2's again, just like the original function here. So I'm going to go up to pi. And then remember how we graph our inverse. So I'm going to use my 3 kind of key points I'll have here. So let's do these 3. So this is the point 0, 1. So then I'm going to have the point 1, 0. Okay, then I have the point pi over 2, 0. So I'm going to have 0 pi over 2. And then I had the point pi negative 1. So now I'm going to have negative 1 pi. And again, be careful on your curvature here, and it's going to stop. And that's the key thing about this inverse. It stops, as opposed to the original function, which normally kept going, but we stopped it on purpose so we don't repeat those values. So if you do a vertical line test on this arc cosine, we're only going to touch one point, so it is a function. So that's why we're stopping it there. So the only angles you should ever give for answers are between 0 and pi. So we're restricting that down so we actually have a function there. So everybody's saying the same angle. Remember how many coterminals there are, right? That could be a disaster. All right, so let's talk about algebraically. How do you find the inverse? Well, we take our original function, we switch the domain and the range, and then we're going to solve for y to make our life easier. Well, how do you solve for y? You do the inverse on each side to get the y by itself. So I'm going to do inverse cosine on each side. And again, it could be arc cosine. Remember, you always have the choice, whichever way you want to write that. They're the same thing. If you do a function and then it's inverse, they undo each other, so we get the y equals inverse cosine of x. So your input, remember, is going to be a ratio, and your output is going to be the angle. So it's the exact opposite of our original functions, where we put in an angle, right, and when you get out a ratio, inverse, right? The domain and the range switch. It's no different than saying 3 times 2 is 6. 6 divided by 3 is 2, right? That same kind of relationship. So again, you could have said, instead of inverse cosine, you could have said arc cosine on both sides. So you could have done arc cosine of the cosine, and it would be the same exact thing. So we always have both of those options. All right, so let's pull together what we know about cosine inverse. So we have y equals the arc cosine of x, or y equals the inverse cosine of x, whichever way you want to say that. The domain of arc cosine is negative 1 to 1. And the range of arc cosine, the angle measurements you should be saying, are only between 0 and pi. Most people like this because it's quadrant 1 and 2, which is a little bit easier for people to visualize, I think. All right, so what are they meaning when they say arc cosine of a half? That means for what angle is cosine of x equal to a half? When does that happen? So for what angle? Well, the answer is there's infinitely many, right? There's lots of places where cosine is a half. But to make this a function, I don't want infinitely many. I want one. I want the one angle in 0 to pi where cosine would be a half. Okay, well, first of all, it's positive, which means this is going to have to be a quadrant 1 angle. So we're thinking about, okay, cosine of what angle then would make that a half? So which reference angle is cosine a half at? So that's the 60 degrees or pi over 3. So that means this would have to be equal to pi over 3. Now notice there's other places where this would happen. 5 pi over 3 is another place where cosine would be positive a half. If you go back to the graph, like here. Well, I don't want that one though. Notice it's not in my highlighted part. I want the one that's in the highlighted part. So I want the pi over 3, not the 5 pi over 3, or any of the other coterminal angles that you might come up with. So that's the whole idea for inverses, that we're all saying the same thing. All right, let's talk about tangent, and then we're going to do some practice then. Let's graph one complete period of tangent for me. Pause the video and go ahead and graph that. All right, so let's take a look at our one complete period of tangent. Now remember, in regular tangent, there's infinitely many of these, right? So there's one there, there's one there, there's one there, and it continues infinitely in both directions. The nice thing about tangent, if we just limit it to just this one tangent curve, we're going to be able to do the horizontal line test on that one highlighted one, and it's only going to touch 1 point. So the nice thing about tangent, it's kind of the parent graph that you would normally think works really, really well. So we're going to limit this one down to a little bit easier deal. So we're going to go negative pi over 2 to pi over 2. And then the range is all real numbers, right? Because remember, we have arrows on the end, top and bottom. So the limitation works out a lot better in this one to make it something that's a little bit easier to deal with. So we have angles on the x, ratios on the y. So that means when we do our inverse, we're going to have ratios on the x and angles on the y. So that means our domain is a ratio, right? And our output is an angle. So we're always thinking about that being flipped. All right, so let's go ahead and see if we can get this graph. Now, if you think about the original function being something that's going up and down vertically, what you're going to have is something going across or horizontally on this inverse. So we're going to have our ratios, and I'm just going to do -1 to 1. I'm going to go negative pi over 2 to pi over 2. So kind of keeping the same, and our pi over 4 is in between. All right, our vertical undefined places. So what happens to a vertical line if you switch the domain and the range? It becomes that horizontal line. So we have a horizontal asymptote at pi over 2 and negative pi over 2. Let's take these points and switch them. So negative pi over 4, -1 would be -1, negative pi over 4. 0, 0 is going to be 0, 0, and then pi over 4, 1 becomes 1 pi over 4. So you get this nice curve going across. Now, if you take a look at that red curve and you do a vertical line test, it is definitely a function. You don't have all the other ones stacked above and below because we restricted that original function to only have one of them. So when we flip the domain and the range, we only have one of them. So our domain now is all real numbers. No worries, that's totally fine. And our range, though, is what's restricted, negative pi over 2 to pi over 2. I'm wondering if you noticed something about how I wrote the range and then the domain over here, parentheses, because it can't actually equal pi over 2, right? It's the same issue we have that's undefined, so I'm going to use parentheses. So it has the same numbers as what it did for inverse sine. It's just that it's parentheses instead of brackets because I can't include those values. All right, so again, I know we've done this before, but how do I find the inverse of tangent? Well, I switch the x and the y, and then I solve for y. So I do the inverse on both sides. I'll go back to arc on this one just for kicks and giggles here. So the arc tangent on each side, I do the inverse function. So the arc tangent of the tangent of y, if I do one function and then its inverse, they undo each other, and I'm left with arc tangent of x. Or again, inverse tangent is fine as well. All right, so how can we write this? We can write it as arc tangent of x, or we can write it as y equals inverse tangent of x. The domain, what are the inputs? Anything we want, negative infinity to infinity. Domain is all real numbers for inverse tangent. The range, though, is only pi over 2 to negative pi over 2, not included, so exclusive. So no parentheses there because it's undefined at those places. So again, just like sine, we have to be careful how we answer if we look at a negative ratio. All right, so what are they asking you if they say arc tangent of square root of 3? That is asking you for what angle is the tangent function, so tangent of what, equal to square root of 3. When does that happen? Because remember, inverse means angle. If you're asking an inverse, you are looking for an angle measurement for these trig functions. So inverse means angle, so think of it that way. What angle does this happen at? So when is tangent root 3? Bigger angle, bigger ratio, steeper slope? That happens at pi over 3. So what you're looking for in this situation, if you go back, is you're looking for that 60 degree when is it square root of 3, which is like 1 point something. All right, 1.7, something in that ballpark. So that's what we're trying to do for inverses. We're trying to be able to evaluate, just do the reverse operation. So we're going to practice a bunch of them. So we're going to go through and try several just numerical things, trying to figure out what angles that would be. So we need to get our unit circle fresh, and then we're going to practice just typing in a few in our calculator. All right, so let's start with some of these examples here. Okay, arc sine of 1. Okay, so I always want you to think about what that means. Arc sine of 1 is asking the question, for what angle measurement is sine 1? So think of it this way, sine of what angle is equal to 1? So for what angle measurement would make that true? So go ahead, pause the video, think about your unit circle, and let's think about, see if you can come up with your guess, and then we'll come back together. So I always want you to guess first, and then come back and listen to the explanation. All right, so remember what our range is for arcsine. So we know that it has to be an angle between, if you go back to sine, negative pi over 2 and pi over 2. Okay, so that means it's like quadrant 4 and quadrant 1. So if you think about the unit circle from that perspective. So since this is a positive number, right, that means it has to be a quadrant 1 angle. And when is sine 1? Well, that happens at pi over 2. So this would be equal to pi over 2. So you're asking for what angle measurement is sine 1? That's pi over 2. Because remember, sine of pi over 2 is 1. So we're just going in the other order, just like multiply and divide. Okay, let's try the next one. Inverse sine of a half. Asking the question, for what angle is sine? So what angle measurement has to go there? When is that going to make sine a half? Okay, so pause the video. What's your guess? What angle measurement gives you a half for sine? And again, remember, sine, we're negative pi over 2 to pi over 2, so it has to be an angle in there. All right, smaller ratio here, so when is sine a half? This is the Rosetta Stone for many people. That happens at 30 degrees or pi over 6. So the answer would be pi over 6. So you're looking for what that value would be. And we'll check a couple of these on our calculator here in a second so we can see how we can tell if we're right. All right, arc cosine, square root of 3 over 2. So I'm just trying to use different things. Arc and this inverse, that means the same thing. So arc cosine, again, that's asking the question, for what angle is cosine root 3 over 2? Go ahead and pause the video and see if you can come up with what angle is that. All right, so remember what the range value is for arc cosine. That means we're looking for an angle between 0 and pi. All right, so when in 0 to pi would cosine be positive? So this is like quadrant 1 and quadrant 2, right? If it's positive, that means it has to be a quadrant 1 angle. And root 3 over 2 for cosine, that's the longer leg. That would be happening at pi over 6. Okay, now say you wanted to double check your answer on your calculator. I want you to be able to do these exact. You're not going to be using a calculator, but what if you wanted to check on your own? Let's go to your graphing calculator for a second here. I'm going to do this in degrees because I think it's easier to recognize. So I'm going to go ahead, oh, mine is in degrees. I'm going to do that last, or the middle one, inverse sine of a half. To type in inverse, you do second and then sine. Notice the inverse sign right above. And I'm just going to put in the half. I did it in degrees because I think it's going to be easier for you to recognize. 30, right? So you put in the ratio, I'm getting the angle. So 30 degrees, that's why I came up with this pi over 6. So I can check my answers. All right, let's try a couple more. Let's do a tangent. Inverse tangent of 1. Asking the question, for what angle is tangent 1? So tangent of what angle would give me 1? All right, pause the video. Come up with your guess. When is tangent 1? All right, and remember tangent, we need to be looking for an angle measurement between negative pi over 2 and pi over 2. That means we're looking in quadrant 4 and quadrant 1. But remember, quadrant 4 meaning just going down. A really good way to think of it is like reference angle. So think about what reference angle would give you that, and then it's just going down instead of up. So we'll take a look at a few of those when we get to some negative values. So when is tangent 1? Well, that's at pi over 4, right? 45 degrees. So at pi over 4, tangent would be 1. Easy one to check on your calculator. Let's try one more of these and we'll get to some negatives. Inverse cosine root 2 over 2. So that means for what angle is cosine? So we're looking for this angle measurement that would make your answer root 2 over 2. So when is cosine root 2 over 2? That happens at pi over 4. So that's what we're looking for, that angle measurement. Now let's try some of those negatives because that can be tricky for people. So we're going to do 3 different negative values. Inverse cosine of negative 1. Okay, so I want you to give this one a whirl, see what you think the answer should be. For what angle is tangent, or did I say cosine? I meant tangent. For what angle is tangent negative 1? When would that happen? So thinking about it like this, tangent of what would give you negative 1 for your answer? So we're looking for that angle measurement. And again, remember, we need to be in what range here for angle measurements? What's the restriction for tangent? Negative pi over 2 to pi over 2. Okay, so for some people, they think about, okay, well, what does the reference angle tell me? When is tangent 1? Let's start with that. If tangent was regular old 1, that reference angle would have to be pi over 4 or 45 degrees, right? That's when tangent is 1. But because it's negative, that means I'm going down into quadrant 4. I'm going into that before the y-axis. So that just means my final answer then is going to be negative pi over 4. So I'm going the same distance. That's what the 1 is telling me. That's the reference angle part of it. It has to be pi over 4. Negative means it's just going to be negative. You go down pi over 4 instead of going up. So if you think of it that way for tangent and sine, it really does help. It's always the reference angle. You would never want to answer this as like 3 pi over 4 or 7 pi over 4. Those are places where tangent's -1, but they're not in this restriction, and that's the thing you have to get used to. We all want to answer the same exact angle. So if you're picking a different angle that also, yeah, they're -1, but they're not in that restricted range, we're not going to be able to communicate as easily. So that's why we have that restriction. So just be careful with how you name it. Okay, arc cosine of -1/2. So think about cosine here. So that's asking the question, when is cosine equal to -1/2? For what angle measurement? So we're looking for that angle. All right, so what's the restriction for cosine? Well, that one's 0 to pi. So we need to pick an angle that's between 0 and pi. Pause the video, see if you can come up with your answer. When would cosine be -1/2? All right, so I start with reference angle again, so think about reference angle. So the reference angle, when is cosine equal to 1/2? Well, that's at 60 degrees or pi over 3. Okay, when it's negative, that means it's pushing me into quadrant 2. So if it's putting me in quadrant 2, which angle measurement for cosine has a reference angle of pi over 3 that's in quadrant 2? Well, that's going to be 2 pi over 3. And that fits into my 0 to pi. So it's kind of like what you're dealing with for tangent. We have to know how to name it correctly. But this one, we don't have to just think reference angle. We can just pick the regular angle you probably would come up with anyway. It has to be the one in that restriction. So because it's negative, I know it's in quadrant 2, 0 to pi, right? It has to be in quadrant 2. My reference angle is pi over 3, so that means it's got to be 2 pi over 3. I wouldn't be able to pick, say, 4 pi over 3, because that's not in the restriction 0 to pi. All right, let's try one more of those. You'll get better at it. You just have to make sure you're naming the right one. Inverse sine of -√3/2. So that's asking the question, when is sine equal to -√3/2? So we're looking for this angle right there. So pause the video, give it a whirl, see what you come up with. All right, so remember what the restriction is for sine, -pi/2 to pi/2. So we're looking for an angle in one of those two. So let's break this down again and think reference angle first. So what reference angle for sine would give you 3 pi/2? Well, that's the bigger ratio, so that's going to be at that 60 degrees, so it's going to be pi/3. Now, because it's negative, that means we're just going to go down pi/3 instead of up, because remember, we're going -pi/2 to pi/2. It's just reference angle, so that means we need to have the one that would be located in quadrant 4 going down, because it's negative, right? So that just means my final answer would be -pi/3. I can't say 5 pi/3. I know that's the same location, it's coterminal, but it's not in this restriction. So for sine and tangent, it really becomes a matter of just the reference angle and making it negative if you have a negative ratio, because you're going to be going down. If you think about your restriction, -pi/2 to pi/2, so this is your restricted area here. We're just going down that reference angle instead of up. When you're doing cosine, you can just think of it in a normal sense. You're going 0 to pi, so you're just looking at if it's positive, it's your quadrant 1 angle, and if it's negative, it's your quadrant 2 angle. So that's really the breakdown of how we do those. All right, let's talk really quick about your calculator. Be careful that you're in the right mode. Notice all of these are radian measure. So I'm going to go back to my calculator here, and I'm going to switch my mode to radians, make sure I'm doing the right thing here. This is just to help you practice typing these in and making sure you're okay with that. So arc cosine of 0.85. First of all, let's double check. Is that in the domain of inverse cosine? I'm going to go back to inverse cosine. Its domain is -1 to 1. So is this a legitimate number to type in? Is that in the domain of -1 to 1? Yes, so it's totally fine. That's something that we should be able to do. So on your calculator, inverse cosine of 0.85, and we end up with our 0.5. however far you want to go. Where it says 4 places, I think, 5548 then. So 0.5548. So it's a little bit bigger than a half. All right, let's talk about the next one. Arc sine of 3.1415. Okay, so what's the domain for inverse sine? Let's go back to our inverse sine, oopsie daisies, and find our domain. So inverse sine, domain is -1 to 1, right? That's our restriction here, -1 to 1. Gosh, why won't that slide? Sorry about that. Got to try to get it to slide. So the domain is -1 to 1. Is this in the domain of that function? Is 3.1415 in -1 to 1? No. So for what angle? If you think about the question, if you're asking the question for what angle, that's what inverse means. For what angle is sine of x equal to 3.1415? What angle would that be? Can sine ever be that? No. So I don't think there should be an answer to that. Watch what your calculator does. So if you do inverse sine of 3.1415, yeah, it's not allowed. It's not in the domain of the function. You can't do it. So if you get a message like that, double check and take a peek, because that doesn't make sense. There is no solution to this at all. So be careful. You can't just do anything you want. You have to make sure that the value is in the domain of your function. All right, arctangent of 4.84. So I'm double checking this number is 4.84 in the domain for inverse tangent. Okay, let's go back to our domain for inverse tangent. The domain for inverse tangent, oh, negative infinity, infinity. Remember the arrows? I can use anything that I want. Oop. So I'm going to go ahead and type that in because the domain is all real numbers. We are good to go. So let's try it here. So second tangent 4.84. And sure enough, I get a value. So out of 4 places, it looks like 3671 for my final answer. So just be really careful. When we're evaluating for our inverses, we really do have to keep the domains and ranges straight. We restricted to make sure that we'd have functions. So that's inverses, really important operation if we want to solve equations with trigonometric functions.